Okay, thank you. Thank you. Hi everyone, and welcome to the Cloud Native Meetup. My name is Sachin, and I'm a product manager in Oracle Labs. With me, I have Chris, Martin, and Hiri, also from Oracle Labs. Today, we are excited to talk about Graal Cloud Native, abbreviated as GCN, and our integration with OCI services. We will also show you how you can easily use these from VS Code. I'll begin with a quick introduction to GCN, and then Chris will talk about and demonstrate the VS Code extensions. So let's get started. So what is Graal Cloud Native? GCN or Graal Cloud Native is an Oracle build of the open source Micronaut framework. We take the source code from selected modules from the Micronaut GitHub repo and build it inside Oracle, test and upload the libraries to Oracle Maven, and then provide support for these modules and libraries. GCN includes a curated set of cloud agnostic modules for services like object storage, databases, vault secrets, and a number of other services that you would typically use in your cloud Java applications. GCN modules are designed for ahead of compilation with GraalVM native image. This means that you can, if your applications use GCN, you can easily convert them and deploy them as native executables. And the advantage is fast startup, less memory as compared to traditional JVM-based applications that you generally deploy as jar files. The GCN also includes tools like Launcher and CLI. These help you generate code to get started quickly with the product. We also have VS Code extensions. You can use these to develop the applications on your local machine and then deploy directly to OCI and other clouds directly from VS Code. So what are the benefits of GCN? GCN improves developer productivity. So GCN has out-of-the-box integration with public cloud services. This saves obviously precious time as people write and develop cloud-native applications talking to public cloud services. GCN also uses the compile time validation feature from Micronaut and helps you detect problems as you're typing code. And you don't have to wait for running the application and finding out that there is a problem in the code that you're writing. GCN apps are faster and cheaper to run at scale. This is because GCN uses native executables, or GCN applications can be easily compiled to native executables, which makes your apps smaller in size. They start really fast and require a lot less memory to run. So this should help you improve the efficiency of your application and reduce your cloud costs. GCN is fully supported on OCI. So your OCI subscription already includes an entitlement to GCN support at no additional cost. You can file tickets, you can get help from our Micronaut experts. You can get security fixes, software updates for GCN Micronaut modules directly from us, from Oracle. GCN modules are cloud agnostic, as I've said. Our vision with GCN is to provide these cloud service abstractions. So once you write your application once, and then you can run it on any supported public cloud. Today we support OCI and AWS, and we have GCP and Azure on the roadmap. So they should be coming soon. And the advantage is that you don't have to worry about learning proprietary cloud APIs and libraries, and thereby prevent cloud lock-in. So here's a view of a quick view of the cloud services that we support in GCN today. It's across OCI and AWS, and we are working on GCP and Azure, as I've said right now. You can use these modules in your Java applications. For example, in databases, we support MySQL and Oracle autonomous databases. In your application, you can use these and store secrets in the OCI Vault and use the Vault Secret Management module to access the database credentials directly in your application. We also support object storage. You can deploy your applications as containers to OKE and use cloud logging, metrics, and tracing for diagnostics. Here's an example of the power of GCN. So with GCN, you write a lot less code. As you can see on the left-hand side is a traditional Java sample code, using the OCI SDK to read a secret from the OCI Vault. You can see all the boilerplate that we generally see in typical OCI SDK usage. And then on the right-hand side, we see the Graal native equivalent of writing the same code. So here you see that all I'm doing is a few configuration variables. I am providing the OCI Vault ID and the secrets compartment ID. And with a single line of annotation, I'm able to extract the secret directly in my code. So that is the value that GCN brings to Java and micro application development. With this, I think we'll quickly jump into the next section, which is about the VS Code extensions that we have for GCN. And I will hand over to Chris to tell you a little bit about the extensions and then demonstrate the extensions. So over to you, Chris.
Thank you very much, Sachin. Hi, I'm Chris Foster. I'm also a product manager at Labs, and I work mostly with Graal Cloud Native and the VS Code extensions. And I think one of the key things that I want to show you today is that using our tooling for VS Code enables you to work with Graal Cloud Native more easily. We provide a number of different tools that makes building, deploying, developing these applications hopefully easier. So I'll do a bit of an overview of what we provide with the tools currently. We have more things on the roadmap, but right now, these are the main areas that we feel that we deliver value. We provide support for Micronaut in that we have a number of features that enable you to work well with Micronaut. We have support for a REST Explorer. So, when you build your REST APIs in Micronaut, you're able to view them in a special pane and make calls against those REST endpoints. We provide completion for configuration files. We'll see a bit of that. And we provide a number of other key features that make working with Micronaut applications that much easier. We also provide support for Micronaut data. So if you don't know, Micronaut data is part of the Micronaut framework that lets you interact with databases. It's a nice way to map your entities and your data like classes directly onto the database. So we've got some functionality, and we'll see a demo of this later, that lets you talk to an existing Oracle Autonomous DB and then extract from the schema. So, there might be the HR schema, and we may have tables in there like country, job, employee. We can take that information, those tables in the schema, and generate entities within our application. So we've got support for taking an existing DB application and then turning that into a Micronaut application using Micronaut data. So we'll see a little demo of that later, and hopefully you'll find that interesting. We've got support for Graal Cloud Native. So we provide a launcher application embedded in VS Code. So within VS Code, you can create a new Graal Cloud Native application. Very easy to use. It's based on the web-based launcher, which we'll probably show you later on, but it leads you through the process of selecting what you want included in your Graal Cloud Native application. And finally, we also concentrate on making building and deploying your application with Oracle Cloud easy. So we provide support for using the OCI DevOps service. So if you don't know or you haven't used the DevOps service yet, it's a hosted service within OCI that lets you basically manages your source code repository and manages your build and deployment pipelines. Using our tool, we can take an existing Grok Cloud Native or Micronaut or Spring app, and we can generate a DevOps project for you, push it into the cloud, all with very minimal interaction. Basically, you just have to click on a big blue button and select where you want this to be deployed to. So we'll have a demo of that today, and we'll see how that works. And then finally, using this OCI DevOps functionality or this integration that we've built, we make it really easy to deploy your application to OKE, which is our hosted Kubernetes engine. So when we set up this DevOps project with your code in it, you can build it from inside VS Code. And once you've built your container with your application in, you can then easily deploy that application using the deployment pipelines we write for you to have it deployed into OKE. Can I have the next slide, Sasha? Thank you. So before we look at some more of the detail, really, I wanted to talk a bit about embedding in the defaults. VS Code isn't the default editor for Java yet, IntelliJ is, but it does have about 23% of the market, and it's growing steadily over time. The default Java support in VS Code is the MS Java extension pack. So if you have a vanilla VS Code and you open a Java project from disk, VS Code will suggest that you install the MS Java extension pack, and it's very much the default. So most people who are doing Java development using VS Code will have this extension pack. We've begun the process of embedding ourselves into the default so that we make it easier for other people to find our stuff. So for instance, as part of the MS Java extensions, they provide a new Java project wizard. So this, like our GCM wizard, lets you create a new project. We've extended that so that you can create Micronaut and Grok Cloud Native applications without having to go off and find our extensions, install them, even know that they exist, right? You can just say, I want to create a new project. You would see Grok Cloud Native in there or Micronaut, and you might think, okay, that's interesting. But by clicking on that, that will cause some of our extensions to be installed, and then straight away you can create a Grok Cloud Native application. So I'll show you a little bit of that before we get stuck into the demos. Next slide, please, Sachin. Okay, so we've also extended another part of MS Java, which the MS Java extension pack, which is the ability to install a JDK. So when you install VS Code and it installs this MS Java extension pack for you because you open a Java project, it will ask you to install a JDK if it can't find one. And there were a number of options available, but Oracle GraalVM wasn't available, the Oracle Enterprise Edition of what used to be called the Enterprise Edition of GraalVM. With the change to GFTC, the new license, we've now submitted a change that embeds Oracle GraalVM in there into the installer wizard inside VS Code. So now from inside VS Code, you can also install GraalVM. It's all about trying to make it easy for people to access, GraalVM and our tools. So next slide, please, Sasha. Micronaut support, if we jump onto the next slide, we're going to look, I've got a few slides here that show some of the features, but we'll see some more detail when we actually do the demo. One of the really useful, if you go back to our session, one of the really useful features that I find anyway is support for properties files. So Micronaut is very much, there's a lot of configuration files that using configuration files basically, as we saw in the sample slide earlier about the difference between using the OCI SDK to set up the Vault and then using Grok Cloud Native to set up the Vault. You probably remember from that slide, there was some configuration properties and then there was like one annotation you needed to use on your data class. Well, configuration is really important in Micronaut. So we've got good support for auto-completing these configuration properties. Currently, we support YAML, which was the standard in 3 whatever of Micronaut and GCN. With the switch to GCN 4 and Micronaut 4, this has now moved to properties files. And I think in the next release, or very soon, well, basically soon, we will be delivering support, the same kind of support for properties files within GCN. And again, it's all about trying to make it easy to configure a Micronaut and GraphCloud native application. So next slide, please, Session. I talked a little bit earlier on about how we can take a Oracle ATP database with a schema in it and generate classes. We're going to be doing this using Micronaut data, which is kind of a part of GraphCloud Native, because GraphCloud Native is a curated set of Micronaut modules. That's one of the key features really in our Micronaut support, this ability to take an existing database schema and from it generate classes that represent the tables inside your database. So we'll have a look at this in one of the demos. So next slide, please, Sasha. And then finally, we've got some slides on the DevOps support. So I've kind of really talked about what we're doing here. We're trying to make it easy for you to set up an OCI DevOps project that contains your Java application, right? Your GraphCloud native Micronaut Spring Boot application. When you have like GraphCloud native application, using this tooling from inside VS Code, you will be able to push this to OCI DevOps and have an OCI DevOps project set up for you with sensible defaults, with build pipelines and deployment pipelines. You won't need to configure any of that yourself, really. If there's an OKE cluster in the compartment that you push your code to, we'll automatically discover that there's an OKE cluster there, and then we'll wire that up into the DevOps project for you. So we're trying to make it easy for you to get your applications deployed on OKE, and as much as possible, trying to get you not to have to leave the editor, right? We don't want to break your flow. You're inside the editor writing your application. It should be easy to build and deploy your application from inside the editor. So again, we're going to show you that today in one of our demos. Next slide, please, Sasha. As part of the deployment to the OCI DevOps service, we use the application dependency management. This is a service inside OCI that basically, when you upload your project, it will analyze the dependencies that are contained within the project, and it will look at those dependencies against a database of known CVEs, so critical vulnerabilities and exploits. So as you push your project to the cloud, to OCI, we automatically do a vulnerability check, and you get the results of that vulnerability check directly back into your VS Code output here. So in the problems pane of the output window inside VS Code, if there are any vulnerabilities, you'll be notified in here. You won't need to switch to OCI to go and find some report that says, you have a vulnerability in your application. We're trying to expose that useful information to you directly so you can do something with it. So it's all about trying to make the process of developing these applications easier for you. So next slide, please, Sasha. So that was a bit of a whirlwind tour. Everything I've talked about, we're now going to see in the demos. So I'm just going to tell you what we're going to do with the demos. We've got 3 demos. The first of these is about creating, running and deploying a GraphCloud native application. So from inside VS Code, we will create an application, a GraphCloud native application. It'll use object storage. We'll run it locally and we'll push images up into an object storage bucket and pull them back down again. Hopefully it will all work. This is all live, so I don't know. Things can always go wrong, but we should be fine. And then we're going to look at the next demo is going to all be about collaboration, right? So when we've pushed our application to into the OCI DevOps service, it's no good if it's just our application. That's kind of useful, but typically we work as part of a team, right? So we want to be able to collaborate with other people. So we're going to see how we can take an existing project, pull it down locally, work on it, and how basically it'll just load into VS Code. You'll see all of the configuration for the build pipelines, the deployment pipelines, etc. So it's really all about seeing how we collaborate with other team members using OCI DevOps as our point of focus. And then the final demo we're going to show you is about building a GraphCloud native application that takes an existing database schema, and we generate data classes for it and repositories, and then we run it locally, and we should be able to query that database application And really, again, it's about taking something that's kind of exists, an existing database schema that probably contains like really useful information, and then generating a lot of this boilerplate code for you. So yes, you could write those entities for yourself, but like as we have the information, we have the schema, we're trying to make it easy for you to pull that into your Java application, create the models that represent the database tables, and then easily and quickly expose them through REST APIs. Thank you. So now we're in VS Code and I haven't got any projects open, etc. The first thing I wanted to show you is how we embed into Microsoft Java inside VS Code. So everything's done through this command palette thing inside VS Code. So I can launch that, I can launch it, and I can create a new Java project. So I'm going to do that. And we can see in here that we've got GraphCloud Native added, and we have Micronaut added. And this just goes back to the point I was talking about earlier about what we're trying to make it easy for people to discover and find our extensions. Another thing you probably want to know is like, how do I install these extensions? If at the end of this talk, you're excited and you think like, yeah, I'd like to use that. So if you have VS Code on the left-hand side, there's an extensions icon. You click on that. This shows you the extensions that you have installed, but you can also search for extensions that you might not have installed. And where you find these extensions, they're all published to something called the marketplace. So if I search for Graal Cloud Native, you can see that there's something here called there's an extension called the Graal Cloud Native Extension Pack. And I've already installed this, but if I hadn't, I'd be able to click on a button here and that would install it. So if you want to try these extensions out, that's what I'd do. Go to them, install VS Code, go to the marketplace, and then search for Graal Cloud Native and install the extension pack. The extension pack is basically a collection of all of our useful extensions, all bundled into one set. So without any further ado, let's get on with the first demo. So I'm going to close the view for that, and I'm going to create a new Graal Cloud Native application. So I search for Graal, and there I can see new Graal Cloud Native project. So I'm going to click on that, and it's going to take me through a number of screens, which let me select what kind of application I want. So I want an application, not a function. It's detected what JVMs I've got available, so I'm going to select JVM. So this is the Cloud Native meetup, isn't it? So Cloud Native. So I'll give it a name, my project a name, and then we get to choose what we call the services. These are the types of cloud services that we want to use. So we're interested in object storage for this demo. So I'm going to select object storage, click OK, and then I want Oracle object storage. So object storage for Oracle Cloud. That's the specific feature I need to use with this service. Click OK. I'm going to say I want to use Maven and JUnit to create my application. And here we get to see, what clouds do we want to build this application for? What clouds do we want to deploy it for? I'm just going to select OCI, but you could choose AWS. And when we support GCP and Azure, they'll be available there as well. So I'll click OK. Do I want to generate the sample code? I'm going to say yes, because it makes my life a bit easier. I'm going to select a folder that I want to create it in. Okay, and there we have our first application. So it was created from inside VS Code. And let's take a look at the application. All Graal Cloud Native applications are multi-module. So we have a module called lib that contains the core application, like the core code. And then for each cloud that we will be deploying to, we have one module. So as I'm only deploying to OCI, I have a module here for OCI. So what does this application do? The sample code generates an application that lets me store an image against a profile name in a bucket on OCI in object storage. It has a few endpoints that are defined in this API. It's not really too important what they do, but basically we can push an image and pull back an image. And we have a controller that implements this API, right? And this has a number of methods for allowing me to upload my application and then to pull it down. You can see actually that it's not a huge number of lines of code. This is another example of how GCN makes it easier to work with cloud APIs. We try to create one consistent logical kind of interface for talking to a cloud service, such as object storage. And we try to make the methods to use that as sensible as possible. So I'm not really going to change the application, but I am going to change the configuration. So if I remember, I said that there was a module for each cloud vendor that I'm using. So I'm using OCI. So then I'm going to go into my OCI configuration file, and I've got to put in some details for, which object storage bucket I'm going to use. And first thing, if you've used object storage on OCI before, you know that there's a namespace and a bucket name, and the bucket names need to be unique within inside that namespace. And I think
I think you have a typo in the namespace. Yeah, developer.
Okay. Thank you very much, Martin. I will check that.
It will not be pushing.
Perfect. I'll just double check that. Let me finish this one and then I'll get that straight. So the bucket name is bucket demo-gcn Oracle developer. The trouble is I've never been able to spell, so that's caused me all kinds of problems. Yeah, so we've just got two properties here that tell the application, how to connect to that object storage. If I was talking to AWS and I wanted to use SW3, there would be a similar but not identical set of configuration that would tell the application how to talk to the S3 bucket. So it kind of really simplifies the process of using this cloud service. And then I can go into my application and I can use these code lenses that are available with our support for GCN and Micronaut to let me run the application. So hopefully, if I've got everything right, this should just work. So from inside my application now, I've hit that run code lens, and that's going to build my application for me and then start it up running. It's looking good so far. Okay, so my application's up and running, and you can see that it's running on localhost. So if I jump to here, so there isn't actually anything on this application as yet. There's no web page. So if I want to actually push an image to the application, I've got to do it from inside Carl. So I'm going to get myself a new terminal open. And I think I've got an image. Yeah. So I need an image file to upload. So I've got my image file there. And so if I search back through my history, curl, it's curl get, isn't it? In fact, I don't even need to do this. I'm being a bit silly. I could show you the REST Explorer. So do you remember earlier on I said we've built support for a REST Explorer? We're able to pull images. We're able to, call REST endpoints directly from inside VS Code. So I think I've got some images up there already. There's my demo bucket. And I believe if I take something like this one here, right. So if I now call pictures user ID, get, okay, this is the one we want to call. And I'm going to call that one. So hopefully, right, okay. Martin, okay, so content created. So now if we go to the bucket and refresh it, we should see that our file has been uploaded. So we could also then call that, we could pull that image back down. So what we've hopefully seen there, apart from my terrible typing and the fact I should have had that curl command like it's the last one in my my history, is that it was really easy to use GCN to talk to object storage. It was really easy to connect to the application, right? We had just a little bit of configuration that we needed to do in order to connect to the bucket. And then it was super easy to run the application by just clicking on run, right? From inside my code. So we're trying to make it very sort of self-consistent and easy to use experience in order to build and use a GraphCloud native application So we've shown that it's easy to build one and that you can run it locally and you can talk to the cloud. That's kind of half the story. But the other half of the story is about pushing it to the cloud. So it's one thing to talk to the cloud, but we also want to operate inside the cloud. We want to push our application to the cloud. So if I close down some of these tabs so that it's not looking so busy, I don't want to save that. On the left-hand side, you can see we have this OCI DevOps panel. And if I expand that, which I have here, we've got this Create OCI DevOps Project button. If I click on this, this is going to use my OCI credentials. I've installed the OCI CLI, and that's configured to talk to the cloud. It's going to use that CLI to query the cloud and to figure out where to help me select where I want to push my application to, right? So I'm going to choose my profile. Then it's going to query all the compartments that I have available in the tenancy. And I want to push it to my OKE clusters compartment. So I'm going to do that. And it can see that I've got a couple of Kubernetes clusters in there. So I'm going to choose the first one. And then down here, you can see that it's busy reading various different things. It's going to ask me what I want to call this DevOps project. So what it's going to do is going to take my source code. It's going to create a DevOps project. It's going to configure the DevOps project for me. And really, I don't have to do a great deal. And as part of doing that, it's going to create a GitHub. It's going to create a Git repo for me inside the DevOps project. It's going to commit all of my code into that repo. And you'll see that this will all change color shortly to show that it's been checked in. It's going to create the build pipelines and the deployment pipelines. It's going to create it's going to create Docker files for building JVM and native versions of my application. So it's going to do a lot of the heavy lifting for me and hopefully just make it easy for me to start using the OCI DevOps service. Okay, so it all changed color. It's now currently checking it into the code repository inside the DevOps project. And if we go over to the Cloud Console again and we select, go and search inside developer services, DevOps projects, and yeah, I think that was the name of the project I created. So it's created a new DevOps project for me. And there we have it. So now we've got these extra icons available in the OCI DevOps tab. I'm not going to run these now because provisioning a build runner and then doing a build might take a few minutes. But the main things you can see here are that we can build a container of our application that's based on a native executable. We can build a JVM version, so that packages the JVM and just uploads our jar into it, but it's our application packaged as a container. And then we can deploy these containers directly to OKE. And this is all done by just clicking on this kind of play icon. So that's the end of demo one. And that's kind of half the story, as I alluded to before. It's great to be able to create an application, then run it locally. And then it's even better if we can push that application to the cloud. But typically, we're going to operate as a team. So if we're operating as a team, we want to be able to share our applications, right? So I'm going to create a new window, new VS Code window. And what I'm going to do is I'm going to import. Actually, I need to do it from inside. Oh, no, from here, from the big blue button. I can import a pre-existing DevOps project. So again, this is going to use my OCI CLI. It's going to talk to the cloud and it's going to ask me which compartment I want to look in for my project. So my OKE clusters compartment. And then I've got a bunch of projects here. So I'm going to select this one that I created a couple of days ago, demo object. And it's going to ask me where I want to have my local copy of that. So I'm going to put it in this imports folder. And you can see down here, it's busy doing something. So all the time it's talking to me, telling me what it's doing, right? So let me just clean up some of these. There we go. These windows. So it's taken that DevOps project. Say I'm another developer on the team. I've now been able to pull that project locally. And I have all of the code. The code is managed in a Git repo that's shared centrally via, well, you push your changes to a shared Git repo inside the DevOps project. And down here inside OCI DevOps, the OCI DevOps tab, we should be able to see the build pipelines and the deployment pipelines that have been set up for this previous project. Now, I think I managed to, let's run the deployment. So I think I've already built the container for this. So the deployment should be a relatively quick process rather than building the container. So this will take a container that's been pushed to the OCI container repository that has been set up specifically for this project. It will pull a container from there using some standard default names that are associated with your project, and it will then deploy it to OKE. So again, you don't need to use the Kubernetes plugin or kubectl to do this. You can do if you want, but some of the basic functions that you want to do all the time, such as deploying your application, that's all embedded directly into the tooling. And earlier on, we also mentioned about the vulnerability reports. As part of the project being in OCI, you see that we get this vulnerability report directly embedded into our coding experience. So we're trying to not distract you from the flow of your development. You want this information where you're working, which is inside the editor. So this will push the application. I think I'm a bit worried that I'm getting a bit long on time. So if this doesn't complete super quick, we might jump onto the last and final demo, which is the DB demo. But one of the things I wanted to show you as well, whilst this is running, is about how we are embedding ourselves into OCI as well. We're trying to integrate well into OCI to make this experience smooth for you. So for any of these tasks, you can have like an extra menu. You can see the log outputs. For instance, if I want to go and look at the JVM container, I can open it in Oracle Cloud Console. There are extra tasks that are available. For instance, I can open particular folders or open different DevOps projects if I want, import as I've seen. And you're also able to add a number of other different kinds of resources, such as if I want to see the artifacts or the containers or the knowledge base output. These are the vulnerability reports that are generated when our application is audited. We can add these to the view here in the OCI DevOps pane so that information is available to you directly. So this is busy running. Hopefully it will finish soon. This is a slightly improved version of the application that I should have built here. I've added a web front end to the application so that there's a HTML page front end, so that when you hit the endpoint, you see the contents of the bucket listed, as well as a form to interact with the bucket to allow you to upload new images. So the last thing I really wanted to show you about this was the automatic port forwarding. So when your application is running on OK, that's great, but how do you access it, right? You need to set up port forwarding. You need to forward the port that container's offering up that it's running on via SSH, basically, to your local machine, so that you can use a browser or curl and access the application running in OKE. So we make that easy by providing port forwarding for you when the application has been deployed. You could do actually. So whilst that's running, let's create a new window, right? And we can move on to the third demo. So the first demo was easily creating a GraphCloud native application using object storage and running it locally and then pushing it to the cloud. The second demo was about sharing that application, working together. And we saw how we could import that application locally, start working on it, deploy it to OKE, and hopefully see that we can access that locally over our machine. And then the third demo was about using our integration with Oracle ATP. So I'm going to create a new application, new GraphCloud native application. I'm going to select my version. Let's say it's a normal application, pick my Java version. I'm going to call that Cloud Native DB-1, right? So this is going to be the DB example. So I'm going to say that I need to use the database and I want to use Oracle. So I'm going to say, I'm going to use ATP. So I'll click on OK. I'm going to use Maven, JUnit. Again, I'm only going to use OCI. I'm going to click OK. And I'm not going to no, I am going to generate my code. I'm just going to customize it. Yeah. So that's going to create my application for me. And so we've got a basic sample code application. So this comes with some, you know, controllers and things. I don't want those, so I'm going to get rid of these. This relies on Flyway to create a database schema for you. So I'm going to have to remove some of the standard stuff that's delivered with the sample code. And then we're going to connect it to a database. Let's see if this is, yeah. So I've removed the original sample code, taking its time, it's scanning, I think. And then I have to make a few small configuration changes because we don't want to support Flyway. And I think I also in here need to remove this. And this. Okay, so I've got my basic application, but it doesn't actually do anything, yeah? There's nothing in it other than like a main class. So I can use this databases tab that we see here to connect, again, using the Oracle, the OCI CLI to connect to the database. So I'm going to hit this button that says add Oracle Autonomous DB. And much like we've seen with all of the other screens, it's going to ask us which profile we want to use. So I'm going to use my default profile, and we're going to go and look for a database within a CIDR compartment. So I know there's a database in my OKE clusters compartment. And that's the database. So I'm going to tell it who I want it to log on as. Hopefully I will get the password right. Let's hope. And then in this window, we ought to be able to see the database, which we can then connect to. So is that connecting? Great, so we're connected to the database now. And we can see our schema. And then if I open the schema, we can see some tables, countries, departments, employees. So this is the standard HR database schema. So that's great, we're connected to a database. Now, how do I pull that information into, my application? I forgot to delete the service as well. So I'm going to go to the domain and I'm going to use one of our templates. So we say new from template and we say Micronaut because it's Micronaut application. And then we're going to select Micronaut data entity classes from database. So this is going to create my data entity classes from the database. And we can see here that we've got all of the tables that we could see in the database. This has been queried live. I'm going to select countries because I know there's data in there. I'm going to click OK. And then in a second or two, we should see inside the domain folder that we have a class created for us, an entity class that represents that database table. Okay, cool. So there we go. There's our country class, and we have some code here that represent a class that represents the database table. And then we can also, inside the repository, we could create a repository that's going to expose the country class. So if we say create Micronaut data repository interfaces from entities, so I'm going to click on that and we can see our country class there, our country entity. I click OK. And so now that's created a repository for us with the find all method. And then if I go to the controller, again, I can create Micronaut controller class. I'm going to call it country. That will create a country controller for me. So I'm going to create a method in here called list. Just try and be as quick as possible. Okay, right. So now I need to pass in my repository. So I need to have my country repository available to me. And Micronaut's going to make it, is going to basically do the wiring. It's going to do the dependency injection to insert this repository class into my controller when the application starts. And I'm going to give this class a constructor, and I say the constructor is going to take a repository. So this is how the dependency injection happens. And I'm going to save basically the reference to that controller. So now when this controller starts up, it will have access to the repository. I haven't really had to do a great deal. And then I can, when this list method gets called, when the /list endpoint gets hit, I can do find all. I can call the find all on it. I can create a stream from that. And on the stream, I can map that. So for each entity, I think I'm going to do something like get country name. That seems like a sensible thing. And then I think it's collect, and I've hit the wrong one there, but it's collectors, and it's, which one is it? It's joining. And we're going to use, we're just basically going to create so we've now taken that database table, and if I make this a little easier to read for everyone, we've gone in a minute or two, we've gone from a database table to a controller that exposes that database table. And hopefully, if I've got my configuration correct and I haven't missed anything out, I should be able to just go into my application now and run it. Okay, no, there's still some code in there. Genre controller to, the test, right, ignore me. Let me close that down. So I've still got tests. Let me delete my test. Okay, now let's try running it. So it's going to build and run my application. And with any luck, we should have an application running locally that will query that remote database. And behind the scenes, a wallet is being downloaded for us. We're using our OCI credentials basically to sort all of that out and connect to the database. And also the tooling, because we know over here we connected to a database, that information is being injected into the running application by the tooling. So I didn't really have to wire anything up. It just knows what database I want to use. So my database is running. And if I go over to here, I can see that I've got my endpoint. This is the Micronaut tools view. I can say that I want to hit the list endpoint to see the countries. And with any luck, if I send a request, yeah, we've talked to the database and we've got back the list of countries. So that was kind of an end-to-end example of how we allow you to take existing data and schemas and turn those into like REST applications relatively easily. And how also we make it easy to connect to the database, right? You're connected via the tools. You don't need to specify that again. We know which database you want to run on. I mean, this works within the context of running your application locally. Obviously, when you're running in the cloud, in OCI, you need to set up secrets inside the Vault, etc. And Micronaut and GraphCloud Native have full support for using the Vault to pull secrets for connecting to a database. But hopefully that's been an interesting demonstration of, the kind of functionality that's possible. So I'm going to kill my application. So that's pretty much end to end of all three demos. Let's go back and quickly see if yes, fantastic. So my other deployment for my other application, do you remember I said it was the object storage? So now that deployment's happened, it's been deployed to OKE. I can see that there's a new action here called open in the browser. So if I click on that, that's going to set up port forwarding for me. So that application running in OKE inside my compartment in OCI is now going to be available locally on my machine. And yeah, what do you know? There we go. The application being served from OKE is now running, I'm now able to access it on my machine locally. And I added a bit to this application, so it's not the same as the bare bones one we saw before. Here we can see the bucket content. So basically I added methods to query the bucket, and then inside the page, some JavaScript to display the call that query method and display the contents of the bucket. So we can see that we have contents of the bucket displayed here. So that's all of the demos done. I'm going to resources, just to give you a flavor. Well, let's go back a section just to remind you of what Graalh Cloud Native is. It's a curated set of cloud agnostic modules for Micronaut. So they abstract away the cloud and let you easily work with AWS, OCI, and in the future Azure and GCP from Micronaut code using Graalh Cloud Native. It's built to be targeting GraalVM native image. We want your target application to be a native executable so that you can target, small memory containers and have that instant startup. So it's built for native image, and we're building a story about making, adding tooling to VS Code that makes it easy to use Graalh Cloud Native, easy to use OCI without having really to leave your VS Code editor. So there's a number of resources that you probably should look at. The GCN guides, if you go to Graalh Cloud Native, we've got some guides, we've got some hands-on labs. These operate on top of Luna Labs. It's a provision environment. You don't have to install anything. It's really good. On OTube, we've also got, if you go to the next slide session, thanks. On OTube, we're starting to upload some videos of the functionality we've built and demos. We'll share that. And the launcher is also available on the web. You don't have to use VS Code, so you can build a zip file with an application in from the Graalh Cloud Native website. And if you go to the next slide, it's worth checking out the Graalh Cloud Native website to find out what's available, what's it about, what guides we've got. And we have loads of guides, and we're always adding new ones.